Welcome to Brain Vision.
Hello friends, as shown in the figure, there is a mechanism attached to the two sides of a rectangular door having the weight 2000 pounds. The ABC of the door is guided by the wheels of negligible mass that rolls in horizontal and vertical tracks. Spring constant K is attached to the wheel. So here K is given spring constant. If door is released from rest at a position, door is released from rest at, that is, velocity is 0 or angular velocity will be also 0. When at theta is equal to 90 degree, angular velocity is 0.6 radian per second. Then we have to find the spring constant. Let us start solving it. We will draw geometrical view of this arrangement. This is the as ABC. It is moving towards right with velocity VA. V is moving downward with velocity VB, and it is rotating with angular velocity omega. I will be instantaneous center. IA will be 5 sin theta, and IB, this is point B. I'm writing here, this is C, 5 cos theta. Velocity of A is 5 sin of theta into A, and that of B is 5 cos of theta into omega. Moment of inertia about the centroid 1 by 12 ml square. Substitute the value. Mass of the door, weight divided by G, that is 32.2. Length is 10 feet. So moment of inertia you will get 51.76 slugs feet square. Kinetic energy T is equal to half mv square half I omega square. Mass is 2000 pound by 32.2. We have defined 5 cos of theta into omega square plus half I 51.76 into omega square. So the total energy we will get 77.64 cos square theta plus 25.88 omega square. Now gravitational potential energy mg into h, that is minus 1000 sine of theta fit into pound. Spring energy, there are two springs are used, so total spring energy 2 into half ks square 5 sine theta. So this can be written as 25k sine of theta minus 0.5. So total potential energy sum of gravitational and spring 25k sine of theta minus 0.5 thousand sine of theta. At position 1, theta is 45 degree, omega 1 is 0, kinetic energy is 0. So potential energy in position 1 will be 25k sine of 45 minus 0.5 square minus 1000 sine of 45. So it can be written as 1.07233 K 707.11. At position 2, theta becomes 90 degree and omega 2 is equal to omega, which is given 0.6 radian per second. Substituting the value, so total kinetic energy T2 you will get 77 cos square of 90 degree into 0.6 square, you will get 9.3168 pound fit. Now potential energy will measure V2 25k sine of 90 minus 0.5 plus 1000 sine of 90. So potential energy at position 2 will be 6.25k 1000 pound into feet. Applying conservation of energy. V1 is equal to T1 is 0, V1 is 1.0 minus 707.11 9.3168 plus 6.25 K minus 1000. So on solving, we will get spring constant K having the value 54.8 pound per foot. That's all for it. Thanks for watching it.